why does it rain? And so I'll start with asking everyone a question, because I think this is the most fundamental principle as to why it rains. What property controls the amount of air or water that air can hold?
Is it temperature?
It is temperature, right? So we've seen this before. There's a formal name for this. Temperature determines the mass of water that air can hold. And the relationship is exponential. So warmer air can hold much more water. This introduces to our imagination this concept of relative humidity, right? So I've kind of indicated here with this little cartoon where these bubbles might fall, right? So basically at warmer temperatures, you make room for more water. That's what this cartoon is demonstrating. And so I'm going to ask you guys to just to make sure we understand this graph properly. And we can also just say it if you don't want to annotate, but color in the region where you have spontaneous condensation of water.
Upper left?
The upper left, right? So above this line, right? So at higher water masses or at lower temperatures, you'll have spontaneous condensation, right? So I might call that the rainfall region. And now I click on this. All right, so we're just going to do the most basic kind of case study here. And I'm going to talk about rainfall in Oregon, and we're going to make some predictions given what we know. I'm getting that every time. All right, so where does the moisture come from for rainfall in Oregon? What's the source?
The Pacific?
Pacific, yeah, it's just right there. That should be easy. All right, what is the topography like across the state? Does anyone know this off the top of their head?
Flat near the Pacific, north-south mountains, and then I don't know.
And then a plateau. Yeah. So you've nailed it. I made this little, there's a tool actually developed by a Lamont scientist called Geomap app. And I did a little cross section here. Right. So there's a little bump. It's kind of flat, but there's a little bump, and then big mountains, and then a plateau. All right. So how does air have to travel over this topography?
It would have to go over the mountains.
Right, it has to go up. And what happens to air as it cools? Or sorry, as it rises? I ruined it. What happens to air as it rises?
Cools.
Cools. Yeah, so this is a property or a principle called the adiabatic lapse rate. This is the dry adiabatic lapse rate. And I think this is actually a good number to have just stored. It's about 1 degree Celsius per 100 meters. Right, so that's why if you climb a mountain, the temperature is going to get a little colder. But so I mean, these these clouds or winds or whatever are going up 2 kilometers or something like that. And what direction would that move? Would that shift a data point on this graph?
The left.
It would shift it left, right, towards lower temperatures, right? And then if we cross this barrier, you'll have rainfall. And so what I've done here is just, take from 97, I guess it's an old map of rainfall, but using this kind of basic intuition here and our knowledge of the Clausius-Clapeyron relationship and some other instincts, I think we made some good predictions about how rainfall is distributed in this region.